Hello YouTube, this is the Heartwood Farmer. I thought I'd come out to the bee yard this morning to demonstrate how to take a sample of honeybees from a colony in order to evaluate the presence of nosema. The tools you'll need are your sample container. What I use are Ziploc sandwich bags. And you'll need the colony that you're going to take a sample of. You want 15 adult older bees. You do not want recently emerged bees, and you do not want nursery bees. So you're not opening the hive to look in the brood chamber to get your sample. Instead, you generally will find older bees on the underside of the outer cover when you open the colony. In this case, there are only just a few bees, and so I'm going to show you how to use the hole in your inner cover to collect a sample. All right, so I simply remove the outer cover and set it aside, and then you can see that the bees are investigating the opening in the inner cover. And so in order to get my sample, all I have to do is cover that inner hole with my bag, and you'll see that the bees readily fly and climb up into the bag. Now I find sometimes if I'm impatient or there aren't enough bees going into the bag, if I tap the inner cover, just like this, it generally gets them excited and they'll come right up. So you can see that I've got more than the 15 bees that I need in this bag. That's kind of important because when I lift the bag up to seal it, I'm going to lose some bees. So I just need to make sure I have enough that after the losses, I still have my 15. So I simply pick up the bag and zip it. You saw I lost a lot of bees, but I have more than 15 left in my sack. So after I have my sample, I simply put the cover back on, pick up my baggie, and walk away. So now that we have our sample, let's talk about how to euthanize the bees. So generally there are two methods that are considered humane for euthanizing the bees. One is to freeze them, which works well if you're collecting a sample and bringing it into your home or into a lab for processing. You would then thaw the bees before you prepare them to be used on a slide. The other method is to use alcohol. And the alcohol method is particularly helpful if you've taken your microscope out into your bee yard and you need to take samples of the bees, euthanize them, process them onto a slide, view them in the microscope, and make management decisions in the field to be acted upon in the field. For purposes of this video, I'm going to go ahead and use the alcohol method. So I just simply take the baggie that I collected the bees in, I shake the bees down, I open the zip just enough so that the bees can't get out, but I can pour alcohol in. Doesn't take a lot of alcohol, just some. And so I pour the alcohol in, zip the bag, and shake the bees until they are thoroughly exposed to the alcohol and they are dead. They have been euthanized. I mean, it's virtually instant. So now that I've euthanized my bees, we collected more than the 15 that we need for our sample. So I need to count out 15 bees to put on my slide. So I just take an empty, I think this is from a mayonnaise jar. It's clean. And I open up the bag and I pour all of the bees into the jar. Lid, which is a little tricky. right. Now, it's important when you collect the bees in the bee yard and you're zipping the bag that you don't crunch any bees. You don't want to contaminate your sample by having a crushed bee, especially if you crush its abdomen and crush its midgut, which is where the nosema resides. If that's all over the surface of the bees and all over the inside of your bag, you've contaminated the sample. So just take care of that. And now I just pick up the bees and count 15 of them. So I should note that the alcohol is not toxic to us. It's perfectly safe to handle with your bare hands. The bees as you count them out into your bag. So we need 15 bees in this sample. So I count 3. Sometimes it's tricky because the bees are kind of stuck together. There's 6. So it may be easiest to pick some up out of the jar and then sort of spread them out on the palm of your hand. Oops. There's 9. There are 12. And there are 15. All right, set the extras over here. Now we add the water. So I just use regular tap water. We use 15 bees in 15 milliliters of water. I measure my milliliters. This is a spare dosing cup that we had from some children's medication, children's Tylenol or something. And it has gradation marks on it up to 10 milliliters. So I'll go ahead and pour 10 milliliters in. I'll have to pour twice into the bag. That's okay. You want to be sort of careful about your measurement. Because the treatment thresholds assume a 15 bee sample in 15 milliliters of water. So in order for your management decision to be in line with recommendations, you want to make sure you've got your sample right. So there is 5 milliliters for a total of 15. So I'll pour the water in the bag. Now, if you have a mortar and pestle, you can put the 15 bees and the water in the mortar and crush them with the pestle. I don't have a mortar and pestle, so I simply crush them in the same bag that I used to collect the sample. So I seal up the bag, I press all the air out, but not the water. I shape the bees down into the bottom of the bag. Now notice the water is essentially clear. And then I happen to have this is an old baby bottle that I'm going to use to crush the bees. You could use a glass, you could use a jar, you could use a rolling pin, anything that you have handy that can be used to roll across the bees and crush them. So what we're doing now is we're crushing the bees, we're crushing their abdomen and crushing their midgut in order to release the contents of their gut. The midgut is where the nosema resides, and so what we're trying to do is to release any nosema spores that are in these bees into the liquid. So I'll just take my jar and roll my jar across the bees. Now when you first start to crush them, you'll feel their exoskeletons breaking, sort of a crunchy sound. You'll notice the water, of course, is becoming very cloudy as the bees' guts are expelled into the water. After you need to press quite firmly. over each of the bees and make sure that each one is thoroughly macerated into the liquid. So when you don't hear or feel the crunching anymore, you know you've probably got a pretty good job. All right, so once the bees are macerated, shake everything down into the corner of the bag as best you can, and then I just sort of use my fingers to mix the water and the bees, just to make sure that any nosema spores that are in the bag are distributed throughout the entire volume of the water, so that when I take my drop to put on my slide, I can be sure that that drop is representative of the entire volume of water here. So the next step is optional. If you wanted to, you could simply take a sample of this unfiltered material and put it on your slide. But if you do that, you'll introduce a lot of sort of extra stuff onto the slide that will confuse the field of view and make it more difficult to notice the nosema. So what I'm going to do is filter the sample. I've shaken all of the water down into one corner of the bag. And I'm going to simply take a square of toilet tissue and I'm going to place it on around my finger like so. This just makes it easier to push the tissue down into the bag. And then I open up my bag and I reach down in there, and now any water that comes up through that tissue that I can reach with my finger has been filtered through the tissue, and I can simply stick my finger in there on top of the tissue and then put a drop that I've just collected onto my slide. And I take my cover slip, and if I place one edge of the cover slip down on the slide first, and then lay the cover slip down on the slide, it'll tend to push the air out and not trap so many bubbles in the sample. I then seal up my bag, set it aside, and I'm ready to do the microscopic evaluation of the sample. So I take my microscope, I remove the last slide that I was examining from the stage. I put this slide into place. I turn on my microscope and I begin my search. I generally start with the slide right up next to right underneath the lens of the microscope, and then I very, very slowly back the slide away from the lens until the material on the slide begins to come into view. I'm also using the stage adjustment controls. There we go. To search across the slide for nosema spores. Now you'll notice that on a freshly prepared slide, the liquid tends to flow across the slide, between the slide and the slip cover. And so it's helpful if you let the slide sit for about a minute, and that allows the nosema to settle out of the water down to and lay on the slide, which makes it easier to find and to count. All right, so I've identified some nosema. There's not a whole lot of it in this field of view, but there are a few spores. There we go. All right. Now, in order to determine whether to treat these colonies for nosema, I need to know what the economic threshold is for nosema. With the preparation that we did, 15 bees and 15 milliliters of water from the colony, I know that if I look at 3 fields of view in the microscope, 3 distinct portions of the slide, and I count the spores that I see in each of those fields of view and then take an average. If I see an average of 15 spores or more per field of view, I know that this colony has a nosema infection that is at the threshold for treatment. If I see fewer than 15 nosema spores on average in a field of view, then I know that my colony has nosema, but it's below the economic threshold for treatment. Now, what that economic threshold indicates is a level of infestation above which the colony will experience sort of economic harm. In other words, it will reduce the vitality of the colony sufficiently that it won't be as productive for the beekeeper. And in some cases, if your nosema count is high enough, you are running the risk of your colony collapsing. So the economic threshold, there's an economic threshold for nosema. When you're evaluating a colony for varroa mites, varroa destructor, there's an economic threshold for those as well, below which you need to monitor the colony to make sure that it remains healthy in all other respects. If you find that you're above the economic threshold for nosema or varroa or whatever ailment you're looking at, then you need to make some management decisions about whether to treat the colony, and if so, how. Now, what I'm going to do is bring my camera over to the microscope and show you a video looking through the eyepiece of the microscope so that you can see the slide and see what the nosema looks like in a field of view. So before we go to the video through the microscope, I wanted to mention 2 things. One is that in order to see the nosema, your microscope needs to be capable of 400x magnification. The second thing is, when I filmed this portion through the microscope, I turned the camera upside down. As a result, you're going to see 3 nosema spores. One is at the end of the needle. I'm going to tell you that the next one is above and to the left, and the third spore is above and to the left of that. So just reverse all of those directions. The first one's in front of the needle, the next one is below and to the right, and the third one is below and to the right again. All right, now you can see right at the tip of the needle, you can see that spore, it's sort of flashing. It's because I'm adjusting the focus of the microscope slightly, bringing it sort of in and out of focus, and you can see it sort of flashes. But you see it has a solid black, the spore has a solid black outline, and it's filled with luminescence. And then you can see above it and a little bit to the left, there's another one. And then above that and a little bit further to the left is a third spore. These are nosema. You can see they look sort of like ovals. And then you can see as well, here are 2
circles that have that same dark outline, and the center of it is it glows. I'm not 100% sure, but I'm 99% sure that those are nosema spores that are standing on end in the water instead of laying down flat like these are.
I hope you've enjoyed this video. We've walked through each stage of the process to evaluate a colony for nosema, from collecting the sample of bees from the colony to preparing that sample to be viewed on the microscope, and then the video that shows you what nosema looks like on the slide. I hope that you'll consider buying or borrowing a microscope so that you can make at least an annual evaluation of your hives about how much nosema they've got. Before getting this microscope, I was guessing. If my bees were not performing well and I knew that I had the varroa mites under control, then I was guessing that the problem might be that they had nosema. When I got the microscope and actually took samples and viewed them under the microscope, I realized that some of my colonies have nosema infestations way above the treatment threshold, but most of my colonies are well below the treatment threshold. And because I've used the microscope, I know with much more certainty what the actual nosema infestation is in my colonies, and that allows me to make much better management decisions that will hopefully help me to maximize the health and productivity of my beehives. So I hope you enjoyed the video. If you could give us a thumbs up below, we'd appreciate it. You might enjoy subscribing to this channel. In addition to videos about the bees, you'll find videos about other projects that we have going on here at Heartwood Farm, including raising chickens, our gardening, our orchard, and other activities. So we hope that you will subscribe and spread the word. Thanks for watching. Have a great day.